Okay. So it looks like um, so I'm getting a late start today, so I have some things to take care of. But we're gonna try and get through as much as possible. Um, I have probably until 4 Central Time, so it's 12:50 right now. Yeah, maybe 4, 3:30, 4 o'clock, something like that. Anyway, so we're gonna do. We left off on 4.7, which is in the middle of types, and then we'll go. It looks like we'll go through some labs, and then we'll start talking about the fun stuff: branching, the if statements. We may or may not get to loops um, today, so we may actually get maybe some of branching done, but loops will probably be tomorrow. Excuse me. Um, so let's get started. And like I always say, if you want me to cover anything specific, just comment, let me know. Um, like the live, um, and or like the video, and uh, all right, yeah, and let's go. Yeah, so if you want me to cover a certain topic or start in a certain area, or maybe if you want me to do more practice tests or something like that, just let me know. Um, oh, and if this is your first time watching the video, I am learning with you. This is like my study session with you guys. So, I read the material, I go through it, I talk it through it, or I talk through it. So this I'm learning with you as we go. So there are gonna be periods where I'm like, I don't know, but I I work to try and figure it out. And then once we do, or once I do, I help you guys figure it out. So I actually, I sit and I do research and things like that when I don't know something. So, but I'm not here to pretend like I know everything or to pretend like I know what I'm doing. This is my little study session that I hope, you can benefit from. So, all right, common data type summaries. Data types summary. The most common Python types are presented below. Common data types. Numeric types, int for integer and float, represent the most common types used to store data. All numeric types support the normal mathematical operations such as addition, subtraction, multiplication, and division, among others. Looks like we have a table here that just describes int and float. So int, numeric type, used for variable with integers, float, floating point numbers. Sequence types, string, list, and tuple are containers for collections. Tuples, by the way, we covered that in yesterday's live session. So if you haven't seen that, you can go check that out. Um, let's see. Sequence types are strings, list, and tuple are containers for collection of objects ordered by position in the sequence, where the first object has an index of 0 and subsequent elements have uh, indices 1, 2, etc. A list and a tuple are very similar, except that a list is mutable and and individual elements may be edited or removed. Conversely, a tuple is immutable and individual elements may not be edited or removed. Lists and tuples can contain any type, whereas a string contains only single characters. A programmer can apply sequence type functions such as len for length and element indexing using brackets to any sequence type. Len and element indexing. The only mapping type in Python is the dict, which is for dictionary type. Like a sequence type, a dict serves as a container. However, each element of a dict, so dictionary, is independent, having no special ordering or relation to other elements. A dictionary uses key value pairs to associate a key with a value. Containers, sequence and mapping types. So type string, sequence type used for text. List, sequence type, uh, a mutable container with ordered elements. Tuple is a sequence type, an immutable container with ordered elements, meaning it can't be edited or changed. Um, set, a set is mutable container with unordered uh, and unique elements. And a dict or dictionary is mapping type, a container with key values associated elements. All right. The list, and then it has here AB3, is invalid because the list contains a mix. I believe that that is false because in a list you can have a mix of strings and integers, so different values. So I'm going to say is invalid because the list contains mix. So that's going to say false. That's correct. Integer and float types can always hold the exact same values. Well, I'm going to say false because integer can only hold a single value, whereas a float can hold a decimal value. And that is correct. A sorted collection of integers might best be contained in a list. A sorted. So if it's sorted, then I'm going to say yes because a list does have a specific sort, like it is sorted. So I'm going to say true. And that is correct. Choosing a container type. New programmers often struggle with choosing a container type that best fits their needs, such as a list, tuple, or dictionary. In general, a programmer might use a list when data has an order, such as lines of text on a page. A programmer might use a tuple instead of a list if the contained data should not change. An example of that is like longitude, latitude. If order is not important, a programmer might use a dictionary to capture relationships between elements, such as student, names, and grades. Choosing among different container types. Okay. Choose the container that best fits the described data. Students' test scores that may later be adjusted, ordered from best to worst. I want to say dictionary on this one because you can have the student with the related value of test scores. So I want to say a dictionary, but the ordered from best to worst throws me off because I want to say list for that. I'm going to select dictionary because of the student and the test scores, and let's see what it says. So I was incorrect. It is a list. So because you want to order it from best to worst, you would want to use a list over a dictionary. Um, so yeah, lists should be used for ordered data, especially if data can change. Uh, a single student, a single student's name and their final grade in the class. Okay, that's a dictionary. What? A single student's name and their grades. Yeah, you have it just got done telling us what a dictionary was, and you know, that's a student and then related information like their grades. But if you watch my last video, you'll see why I chose dictionary because we worked with that in the last video. So, but that's okay. A student's final class grade is a pair of strings that doesn't change. See that right there? I feel like is maybe a little bit misleading, or I can like why it's confusing to me because I mean a grade doesn't have to be a string. It could be like, oh, you got 100%. It doesn't have to be a string. Hmm, whatever. But a tuple is a tuple. Names are current grades for all students in the class. I think it's just messing with me now. Names and current grades. I'm going to say dictionary. A dictionary can provide a map from names to grades, allowing for updates as the class progresses. Example, grades, Alan Smith, B plus. So that's exactly what I was saying here. Student's name, Alan Smith. Uh, what the relationship or the related data or value for that person, the grade, the final grade, the grade B plus, so whatever. Click on the error. Students, student grade program. So it says click on the error. So students equal Joe, Bob, and Amy. Grades equal, and then it has open parentheses. Get student name, grade. So name, input name, grade equals input grade. Assign grades. Grades dot append name equals grade. I feel like so they're trying to create a list here, right? Name, append grade equals grade is assigned grade. I feel like this is incorrect. Yeah, okay, I was right. So a dictionary does not use the append function. Okay. Workers, Joe, Amy. So you'll notice that students has the brackets and workers has the parentheses. Brackets is list. Parentheses, I believe, is no, that brackets is curly braces is dictionary. Sorry, and the brackets is list, and the parentheses. Oh man, is the parentheses a tuple? Well, we'll find out. All right. So workers, Joe, Amy. Remove Amy from workers. Okay. Delete workers one. So index one, that would be Amy. Print uh, Joe, workers Joe. I feel like I feel like delete workers is incorrect. And here it calls for to print out the index of Joe, but because of the parentheses, and I feel like this is a tuple, I feel like this is incorrect, but let's find out. No, I'm wrong. So it was delete. Tuples cannot be modified. So that's what I thought. So this is a tuple like I thought. And I was thinking you couldn't find the index of it, but that may be something else. But delete workers, yeah, you can't modify it. So you'd have to recreate the tuple. So if you wanted to remove Joe or Amy, you'd have to recreate the tuple. All right. All right. Grade calculator. Average score on 3 exams. The following program calculates an overall grade in a course based on 3 quality weighted exams. Grade calculator average score. Okay, so uh, it takes a floating input for grade exam 1, exam 2, and exam 3. The overall grade, so it's going to take exam grade 1 plus 2 plus 3 and then divide it by 3. And then it's going to say your overall grade is, and then it's going to have the uh, average here. So let's run that. And we'll say 89, 90, and let's say I only did 70. So your overall grade is 83. Nice. Oh, check this out. Okay, create a different version of the program. Calculates the overall grade for 4 equally weighted programming assignments, in which each assignment is graded out of 50 points. Hint, first calculate the percentage of each assignment, so score divided by 50. Then calculate the overall grade percentage. Be sure to multiply the results by 100. So it's going to take, calculates the overall grade for 4 equally weighted programming assignments, in which each assignment is graded out of 50 points. Hint, first calculate the percentage of each assignment. So percentage of each assignment, right? It's like 30%, 90%, 80% for each assignment. Example, so first calculate the percentage of each assignment. Oh, so we have to, okay, so then we get the percentage of each of each assignment by doing score divided by 50, right? Then calculate the overall grade percentage. Be sure to multiply the results by 100. Overall grade percentage. So is it saying take all 4? Is it saying to take all 4 percentage assignments and then divide it by 4? And then after that times 100? Multiply the results by 100. So that means we would have to take, right, 4 percentage assignments divided by 4, right, and then times it by 100. Calculates the overall grade for 4 equally weighted programming assignments, in which assignments 1 and 2 are graded out of 50. Points in assignments 3 and 4 are graded out of 75 points. Calculates the overall grade for a course with 3 equally weighted exams. Oh, 100 points. Okay, so these are 3 different things it wants us to do. I'm going to try the first one. I think I'm a little confused, so let's see what I can do here. So we need to take the percentage for each assignment. So we need to take in 4 exams, right? First, calculate the percentage for each assignment. So it sounds like I'm taking these scores and dividing by 50, right? Um, divide by 50. So these will have the overall grade. Wait, so first calculate. So this would have the percentages, right, for the assignment. So score divided by 50. Then calculate the overall grade percentage. Be sure to multiply the results by 10. So calculate the overall grade percentage. So then this will do the same thing then. This will say uh, plus exam grade 4 divided by 4. And calculate the, be sure to multiply the results by 100. So then that means we need to put this in parentheses, right? And then afterwards multiply by 100, it said? By 100. Let's see what it prints out. Let's say 90, 89, 95, and 100. So your overall grade is 187. Now, I don't know if that's right or not. Like, I mean, like, I don't know if I'm doing the math right. I mean, it spit out a number without any errors. Um, so I think I did it correctly, but like, I don't know, like, oh, that's, how you figure out the overall percentage and, things like that. So I, I just know it didn't have return an error. Um, and it seemed to calculate just fine. So, um, all right. Since I started late, I don't want to spend too much time on any one given thing, um, because I want to make sure I'm actually going through the content with you guys. Type conversions. A calculation sometimes must mix integer and floating point numbers. For example, given that about 50.4% of human births are males, then 0.04, I'm sorry, 0.504 times number of births calculates the number of expected males in numbers. If number of births is an integer type, then the expression combines a floating point and integer. A type conversion is a conversion of one type to another, such as an integer to a float. An implicit conversion is a type conversion automatically made by the interpreter, usually between numeric types. For example, the result of an arithmetic operation like plus or times will be a float only if either operand of the operation is a float. 1 plus 2 returns an integer type. 1 plus 2.0 returns a float type. 1.0 plus 2.0 returns a float type. Integer to float conversion is straightforward. 25 becomes 25.0. Float to integer conversion just drops the fraction. 4.9 becomes 4. Type the value held in the variable after the assignment statement given. Num items equals 5, or num items is assigned 5. The value of 5 is how you would really think of it, or how you would say it. Item weight is assigned with the floating 0.5 or 0.5. For any floating point answer, type answer in tens. Example 8.0, 6.5, or 0.1. So this is saying take num items 5 plus num items, which is 10. So that's just an integer, right? Correct. Item weight times num items. So uh, I'm going to get a calculator because I don't do math in my head very well, and I want to try and get it right. So this would be 0.5, whoops, 0.5 times num items 5. So that is the floating number 2.5. Correct. So here we're going to take num items plus num items, which is 10, and then times 0.5 item weight, and that's a 5. Now I feel like because it's a multiplication that it's going to actually be 5.0. So I'm going to do 5.0. And that's correct, yeah. So because of the multiplication, um, it's going to automatically, use a floating point number, even if the 0 is there, it's going to do 5.0. So, excuse me. Sometimes a programmer needs to explicitly convert an item's type. Conversion can be explicitly performed using the conversion functions below. So int. So if you've seen my other videos, we usually do like when we do an input, int and then input. So we're converting a string from the input because the input's always a string. We're converting it to an integer. So can convert integer, float, strings with integers only. A float creates a float. A string creates a string. So these are just the different functions we can use to convert the data or the value. Can convert integer, float, strings with integers or fractions. That's the float. Converting a float to an integer will truncate the floating point number's fraction. For example, the variable temperature might have a value of 18.75232, but can be converted to an integer expression so int and then temperature. So the function int passing temperature through it. The result would have the value 18 because it drops all the digits after the decimal point with the fractional part removed. Conversion of types is very common. In fact, all user input obtained using input is initially a string. A programmer must explicitly convert the input into a numeric type. Strings can also be converted to numeric types. If the strings follow the correct formatting, i.e. using only numbers and possibly a decimal point, for example, int 500, yields an integer with a value of 500, and float with the quotes 1.75, which means that this is a string at the moment, yields the floating point value, so it converts it to 1.75 as a float instead of a string. Run the below program, observe how the type conversion affects the entered number. Change the input to 18.552 and excuse me, and run the program. So we'll run it with 18. Enter a number, original input 18, input text converted to a float 18.0, float converted into an integer 18. So and then it said try putting 18.552. Input 18.552, float 18.552, and then a float variable converted to an integer. So it just drops the decimal. I am curious though, does it round down or does it do round? Because I know there is a round method or a round function that we can do, but I wonder if it's like 18.999, will it round down? It will round down. So it doesn't matter how close it is to being 19. That's actually interesting to know. What is the result of each expression? Integer 1.55 will be 1 since I just tested to see if it would round down, and it does. Float 7.99 will actually be 7.99 because it's a float. String will be in quotes a 99 as a string. I hear something. Oh, I can't see something. All right. Enter the output of the conversion expression. Okay. So let's do this. Number is assigned with the value of 2. New number is assigned number times 2. So 2 times 2. Print new number. Well, 2 times 2 is 4, right? But the tricky part here is that it's multiplication. And I believe that with multiplication, it will turn it into a float. So it's actually going to be 4.0. If you watch my other videos, then you'll know that I constantly forget to hit the return key. And you have to return the return key or it's not going to do it right. So now we have to redo it and say new number. So number and then 2 times 1 is 2. But like I said, it's multiplication. So I think it will do 2.0. And then you have to hit the return key to add that extra new line. Otherwise, it's not going to do it right. Okay, so I'm wrong. Multiplication doesn't necessarily mean it's going to convert it to a floating point number. Let's see here. So 2 times 4 is 8. Now, the last one was an integer, and it wasn't a floating number, so this may be the same thing at 8, which is correct. Enter, sorry, so number is 2.0. So 2.0 times 4.0. Oh, that's not a calculator. 2.0 times 4.0. That's 8. But they're both floating point numbers, so it will be 8.0. That is correct. 3.0 times 2 is 0. Whoops. 3.0 times 2 is 6. But because the number is a float, I believe it will do 6.0. That is correct. Same thing here. Oh, no, this is not the same thing. So now it's converting this number to an integer. So we're just going to get 6 because it will drop that decimal at the end. Now the new number is 6, and that is correct. This is going to convert the integer 9 to 9.0 because it's using the float function. So it'll be 9.0, and that is correct. Number string takes an input. Number float, number string. So it converts the input into a floating number, number int, and then it takes the floating number that it just created and now converts it into an integer. So it wants us to do an output of, so the input is 2.8, right? So print number string. So string will be 2.8 as a string, and then it's going to print number float. Float will be 2.8 without the quotes, and then it's going to print a integer, which will drop the decimal values and just come back with 2. I put the quotes there. You see it, right? You see the quotes there, right? And did I do something? Oh, did I add too many spaces over here? No. Why is it saying I'm wrong? Number float, uh, float number converts the string 2.8 into the float 2.8 number integer. Yeah. So it wants us to print this print number string first, right? That's 2.8. Oh, so the string doesn't, it's not going, it's saying here that the string, yeah, it's going to print out as a 2.8, as 2.8, and the float is going to print out as 2.8. So they look the same. But if we were to take like type, if we were to do like type and then say num string, it will come back with it being a string. It just looks the same. So that's why I put the quotes, because it seemed like it wanted the quotes. I mean, it has a quote here, so it seemed like it wanted it, but whatever. So once again, number in number string 7.6, float 7.6, integer 7. Correct. Bear with me one sec here. One moment. Okay. I am so sorry about that long wait. It was just, yeah, anyway. All right. A string is read from input into variable num minutes. Use a conversion function to convert the value of num minutes to an integer and assign the value to the variable int minutes. So, okay, so it reads the input, a string, an input. Input is always a string. So a string is read from an input right here into variable num minutes. Okay. Use a conversion function to convert the value of num minutes to an integer and assign the value into the. Okay, so it wants us to to create the int minutes variable, and it wants us to convert the input, which is a string, into an integer. So we would say int and then pass num int value into this function. So num minutes. So by doing this, it's going to convert the string if that is being held in num minutes into an integer into int minutes, and then it's going to print it out. So let's check it, and that is correct. Uh, one float and one integer, so float and an integer, are read from input into variable total charge and tip given, respectively. Assign num dollars. So let's create num dollars. I like to break these up into pieces so it's not so overwhelming. So I usually go step by step on it. So assign num dollars with the sum of total charge and tip so that the result is implicitly converted into a float. So I'm going to do float, and it says it wants the sum total, the sum of total charge and tips. So I wonder if I can use sum. Well, no, that's a math. I'd have to import math, so we're just going to do it the different way. So total charge plus tip, tip given. So that's what it wants, right? Num dollar with the sum of total charge and tip given. Okay, so we made it, we're explicitly saying that it's going to be a float and it's going to have the sum of these two numbers together, and that should print it out. Let's check it. And that is correct. Two integers are read from input. So two integers right here into variables grade 1 and grade 2. Assign average, okay, so assign average test grade with the average grade uh, per test, then convert the average grade into an integer. Okay, so I'm going to do int because I know I want to convert it into an integer. And it says to get the average grade per test, right? And the way we do that is um, we take grade 1 plus grade 2 divided by 2, right? Because there's only 2. But we need to add grade 1 and grade 2 first. So I'm going to put grade 1 and grade 2 in parentheses, divided by 2. That will give us our average, and it's converted into an integer like it asked right here. So let's see if that is correct, and I'll check it. And that's correct. Awesome possum. Oh, okay, that was the last one. All right, on to binary numbers 4.10. So thank you for watching. Don't forget to like the live. If you want me to cover something specific, or if you're looking to learn something specific that you're trying to figure out, um, just let me know, and I can go wherever you need help on. Right now, I'm just going in order 1 through 12. So if you do need help on something specific, let me know, and I'll go back and do it. Or yeah. So all right. Let's see. Binary numbers. Normally, a programmer thinks in terms of base 10 numbers. However, a computer must allocate some finite quantity of bits. Example, 32 bits for a variable, and that quantity of bits limits the range of numbers that the variable can represent. Python allocates additional memory to accommodate numbers of large sizes, past a typical 32 or 64-bit size. And a Python programmer need not think of such low-level details. However, binary-based computation is an important part of computer science. So some background on how the quantity of bits influences a variable number range is helpful. Because each memory location is composed of bits, zeros and ones, a processor stores a number using base 2, known as a binary number. For a number in the more familiar base 10, known as decimal number, each digit must be 0 to 9, and each digit's place is weighed by increasing powers of 10. So it has a decimal number of 212, and the representation for the decimal numbers weighted by the powers of 10. So this one's like 2 times 10 to the power of 2, 2 times 100, 200, 212. So if you need to go through this, you can take a screenshot of it, or if you're already like in this class, you can refer to 4.10, but I won't go through this entire thing here. Binary numbers used weight powers of 2. So binary example, which is with 4 bits. So, and then it looks like it's telling you how the math works here on this. Set each binary digit for the unassigned binary number below to 1 or 0. To obtain the decimal equivalents of 9, then 50, then 212, then 255. Note that 255 is the largest integer that the 8-bit can represent. So 128, is it saying 2 to the power 7, right? Uh, I'll be honest with you, this one is a little confusing. If you know how to do it, let me know, but let's see what it tells us. If I put a value here, because I don't think I'm going to get this correct because I'm not too sure what it's even doing. You know, like 2 to the power 7. Like, I mean, let me see something here. Because it's supposed to be like 2 times 2 times 2 times 2 times 2, like 7 times, right? So like 2 times 7 is 14. So that's a no. I think I'm thinking of it wrong, right? So yeah, I think I'm thinking of it wrong. I think it's just telling me. I think it just wants me to say, hey, let's add. Oh, okay. It's not wanting me to figure out the math. It's just telling me, hey, if you were to put 64, which is 2 to the power of 6, here's the decimal value it's going to be. Hey, if you're going to put a or 8, which is 2 to the power of 3, the decimal is now, you know, plus this, plus this, plus this, the decimal value is going to be 201. Okay, so it's just kind of showing us how it's going to compute each value is what it is. So, okay, I was reading way too much into it. Convert the binary number 0.00011111 to a decimal number. So 0, 0, that's 4 zeros. 1, 2, 3, 4. 1, 2, 3, 4. And then 1, 2, 3, 4. So that's 15. Yep. Oh, okay. Here it even tells us 8 plus 4 plus 2 plus 1 is 15, and that's what it's doing. Okay, that makes more sense. So now let's do 1, 0, 0, 0, 1. So that's 136, which takes 128 plus 8 is 136. Convert the decimal number 17 to an 8-digit binary number. So 17. So what's 8? Let's say 6 plus or 16 plus 1 is 17, right? So it's going to be 0, 0, 0, 1, 0, 0, 0, 1, and that is correct. Convert the decimal number 51 to 8 bits. So 51, so 32 plus 16 is, here, I don't want to try and do it in my head. 32, oops, 32 plus 16 is 48. 48, 49, 50, 51. So, and then 2, 3. There. 0, 0, 1, 1, 0, 0, 1, 1. Boom. Correct. Convert the decimal number to binary before the decimal number reaches the binary number. Convert the, here, let's press start. Like that? Is that what it's wanting me to do? Convert the decimal number to binary. Okay, so correct. Okay. Oh, and then you just don't do anything for 0. Okay, that was pretty easy. All right, string formatting. Let's continue to the more fun stuff and not the boring 0, 1 stuff. F-string. If you've seen my other videos, you've already been seeing me use F-string a lot. But let's continue. Formatted string literals, F-string. Program output often includes expressions, such as variables or other calculations as part of the output text. A formatted string literal, or F-string, allows a programmer to create a string with placeholder expressions that are evaluated as the program executes. An F-string starts with an F character before the starting quote and uses curly braces to denote the placeholder expression. A placeholder expression is also called a replacement field, as its value replaces the expression in the final output. So here we can see that it's taking number, putting that variable in curly braces. So the first expression, number, is replaced with the value of the number variable. And then it goes on to read to have string and then another variable in curly braces, and then it reads it and puts it out. So the second expression, amount, is replaced with the value of the amount variable. Select the option that correctly prints the given output. Assume the following code is defined. Okay, so num items cost taco 1.75. I need 3 items, please. So f string, I need num items, so 3, please. So I'm going to select this one because it looks like the closest one to it. So print f string, I need 3, which is num items. Oh, the string. The string items is not right here. That's why. So it's actually going to be this one. So yeah. 3 tacos. So num items, tacos cost 375. So this is not going to be it because cost taco, this right here will only print out 1.25. Whereas it looks like it's actually doing some multiplication. So this would be the correct one. Correctamundo. Additional f-string features. An equal, or like an equal sign or an assignment sign, is provided after the expression in a replacement field to print both the expression and the result, which is a useful debugging technique when dynamically generating lots of strings and output. Example, f, and then it looks like curly braces times 4 equals, produces the string 2 times 4 equals 8. Oh, okay, cool. Additionally, double braces, uh, the curly braces, and so open and close, are used to place a curly brace into an f string. Example, f string curly brace Jeff Bezos curly place colon Amazon's produces the string Jeff Bezos Amazon. So it's like an escape sequence. When you do backslash quotation or backslash period or something like that, it'll print out as a string. So that's what it's doing here. It's printing the curly braces as a string. Uh, and it looks like Jeff Bezos as well. So, all right. F string examples. Print F string 2 to the power of 2 equals. So the output's going to be 2 to the power of 2 equals 2 power 2, so equals, or is assigned 2 power 2. So print F string 2 power 2 equals, and then 2 power 2 equals 4. Okay, so it literally prints the variable name equals 4 because of the equal sign at the end and the answer. 2 to the power of 2 equals, prints this out with the answer, comma, 2 to the power of 4 equals, prints that out as well. Looks like this, because the double curly braces, it prints out the double curly braces and 2 to the power of 2 as a string. Oh, this one has like 3 curly braces, but it looks, oh, okay, so it looks like what it's doing is not only is it printing it out as a string with the curly braces, but it's also giving the value, the result of the expression as well. So that's pretty cool. Um, okay, enter the final value output. Okay, so this should be fun. Output equals, so f string. So this should output just 4, right? Because 2 times 2 is 4. And it doesn't have double curly braces, so it's not going to have the curly. And it doesn't have an equal sign, so it's not going to do 2 times 2 equals and then 4. I think it's just going to print 4. And that is correct. Output. So this one, 2 times 2 with the equal sign inside of the curly brace, single curly braces, this one will do 2 times 2 equals 4, right? And I'm going based off of what we learned up here on how it's doing it. And that is correct. So here it takes inside the single quotations with no equal sign, or I'm sorry, curly braces with no equal sign, and it has kids plus adults. So I think it's going to actually do 4 plus 2, 4, 5, 6, so that's 6, and spit out 6 space total, because it has the total string right here with a space. So kids plus adults, so let's check that, and that is correct. All right, so this one has the equal sign at the end here. So I say it's going to print out kids plus adults equals, and then 4, 5, 6, 6, and then total, because it has the total string here with a space, total, nothing else. So let's check it, and that is correct. Equals after the expression in the replacement field causes the expression and its result to be assigned to output. Okay, so that's what it's, yeah. This one, so it's using, and you can tell by the color as well. So see how this is black and this is black here, and this is green. So this is that color of a string value. So it's going to output curly brace 2 space plus curly brace 3 space equals, and then curly brace, because that's the double curly brace. So that's why it's kind of like an escape sequence. So it's going to print out that one curly brace 5, just like that. Let me make sure I got it all in there. Plus 3 equals 5. Yes, and that is correct. Formats, format specifications. A format specification inside a replacement field allows a values formatting in the string to be customized. Example, using a format specification, a variable with the integer value 4 can be output as a floating point number 4.0 with leading zeros 004 and, and aligned to the left or right, etc. A format a format specification is introduced with a colon. Okay, so we're going to learn about the 2F. Yay! If you saw my other videos, you'll see that the 2F basically says I want 2 digits after the decimal. So it's going to show like this, you see? If I were to change this 2 to, like, let's say a 5, it'll say I want the floating point number to have I said 5, right? Yeah, 5 digits after uh, the decimal. So this would be like 0, 0, 0, 0, 0, 0, blah 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 blah. Okay, so that's what this part is telling us here, is that using colon dot 2f, next to, so 4 colon dot 2f will say 4 dot and then 2 digits after the decimal. So that's what this part's saying, so I won't reread it. A presentation type is part of a format specification that determines how to represent a value in text form, such as an integer 4, a floating point 4.0, is fixed is a fixed precision decimal, so 4.000, a percentage, 4%, a binary, 100, etc. A presentation type can be set in a replacement field by inserting a colon and providing one of the presentation type characters described below. More advanced format specifications like fill and alignment are provided in a later section. Okay, so let's see. So, oh, interesting. Okay, so let's take a look. So type S, string, default presentation type can be omitted. So here it says print out name with the presentation S. So Aiden. So string, default presentation type can be omitted. So it just prints out the string. Okay. D, so for decimal, integer value only. So if we take 4:D, it prints out 4. Decimal, integer value only. Okay. Comma D, decimal, integer value only with commas. So it'll have number, comma D, which prints out. So it looks like this one will add the comma into it because you can't. If I were to type this out in as an integer, I can't type it here. But if I were to type out and assign x to 7,600, I would not be able to use a comma. So it looks like the way it fixes that is by adding comma D to be able to add in that comma to add 7,600. Zero precision D, leading zero notation. So it looks like it's saying it's taking 4 and adding, and then it says :03D. So it's adding 2 leading zeros. Interesting. Okay. B binary value. So it's taking 4 and it :B converts it into a binary number of 100. It looks like X comma capital X, or it's either it's saying probably saying either or comma or either or lower uppercase X. Hexadecimal in lowercase. Oh, okay, and uppercase X. That's why. Okay, integer values only. So it's taking 31 :X, and then it looks like 1F. Yeah, 1F. So that's the hexadecimal. E for exponent notation. So it looks like it converts 44 into an exponent by using :E, which you can see here. Floating point converts it into a floating point. And then 2F, precision, so precision F, so fixed point. So this is 2 leading or 2 digits following, or the amount of digits you want following the decimal. And then comma 2F looks like it's adding the 2 digits after the decimal, including a comma wherever the thousandths is, or wherever necessary. Enter the most appropriate format specifications to produce the desired output. So the value of num as a decimal base 10 integer. So the value of num as a decimal base 10 integer. So as a so is it saying that it wants me to use :D? Oh yeah, okay. Is already defined as a decimal integer 31 in the code, so the decimal presentation type D prints out an unchanged value. Okay. The value of num as a hexadecimal base 16 integer, so the result would be 1F. So the hexadecimal was X. and uh, it looks like it's lowercase. Correct. Excuse me. The value of num as a binary. So I think what was the binary? The binary was, I'm gonna actually take a screenshot of this because I may or may not need it later. If you want, you can take a screenshot of it as well. I'll leave it here for a split second. Because we might need that later. What am I looking for? Hexadecimal, right? Yeah. No, binary, sorry. So the binary was B. Yeah, that's what I thought. Okay. B. Correct. Correctamundo. All right. Each print includes a new line, so create a new line after your output by pressing enter or return. Oh yeah, no extra white space needed. Okay. So basically, it wants us what to type out the program's output. So this would be my name is, and then name. Um, it's going to be Ava, but what threw me off is that this color is still like in that string color, but it's probably just because this is supposed to be an example. So my name is, and then Ava. Oh, if you've seen my other videos, you know that I constantly forget to hit enter at the end of it, even though I just read that it told us to hit enter or return. There. Oh, shoot. This thing just told me my battery's running low. I have another headset somewhere, I think. Okay. Type the program's output. So F string, so thing, car, comma, adjective, tall, comma, color, which is blue. Enter. Almost forgot that again, see? Okay, that should be right. Awesome it is. Okay. Joe was born in the, and it says D, so D is decimal, right? So D is decimal. I'm curious, because it doesn't necessarily say it converts it to decimal, but it says D. So I'm going to do 1990. And I'm assuming that because it's not a decimal point, that it's going to have no change and print it out. What does D mean again? So the way it describes it is decimal. So, oh, this is just saying how to do it. So decimal integer values only. Okay, so, well, and this told us that num is already defined as a decimal integer 31 in the code. So, so the decimal presentation type D prints out an unchanged value. So let's try it that way, see what happens. Don't forget to hit return or enter. Okay, that was correct. Okay, so total num2. So it has the single quotes, and it doesn't have I'm sorry, single parentheses. It doesn't have double parentheses. So it's going to take 70 minus 5, just so that I don't have to waste my time trying to do it in my head. That's 65. So 65. If I can type right. So it should just be total 65. Nothing special. That is correct. Okay. The fish weighs weight ounces. So 9.50. Now it tells us to address it with uh, 2 decimal values at the end, or 2 digits at the end of the decimal, but it already has it. So 50, and then ounces. Enter. The fish weighs 9.50 ounces. And that is correct. Uh, so number D. So it would be 12, comma, excuse me. And it says 04D. So I believe, if I remember correctly, that's going to be 1, 2, 3 zeros, and then the number, and then comma, and then 0.3f, so dot 3f. So we're going to do 3 digits after the decimal. So that would be 12.123 digits. The only one I'm not 100% sure is this one, because I believe it's, whatever number you have here minus 1. So like 04 would 0 preceding, is that how you, leading zeros. If you put a 4, it's going to be 3 leading zeros. That's what I think it is, but we'll see. So no, I'm wrong. So it's going to be decimal. So number presents 12 as a decimal with leading zeros. Well, I mean, yeah, I know it has leading zeros. At least explain how it freaking determines how many zeros. But here it says it should only be 2 zeros. So let's do this. Oh, it changed it. So let's try it again. See, it changes 3 to 3, right? And I believe the example up here was 3. Yeah, 0, 3. So it has 2 leading zeros. So whether you put 4 or 3, it's going to be 2 leading zeros. I mean, I don't feel like it explains that part that well, so I'm going to look it up. But 0, 0, 11, comma, 11 dot 2 zeros, and then 11, oh, just 11. Enter, and let's see if that worked. No, so now it removes 1 0. So it should only be 1 0. So is it saying that there should only be 3 total digits, and that's what it's saying? So like if it's if I said 5 digits, so the actual number takes 2 of those digits, so there would be 3 zeros. I think that's what it's doing. So it's saying that it only wants 3 digits like that with leading zeros, right? And then 11, and then 11.123 following zeros. And let's see if that works, if I'm understanding that correctly. Okay, so that's what it is. It basically, in my head, that says, I want this number to only be 3 digits, and if it's only 2 digits, add the 0 to make up that missing number. I mean, that's the way I'm thinking of it in my head, but select the most appropriate. Okay, so my ear set is dying, so let me get another headset. One sec here. This will be a good time to take a break.